conic section equations are not always written for us in a format that's convenient for us to be able to easily see which conic section we're working with or what its features are. Sometimes a conic section equation is written in this general form where everything is just kind of strung out with the x squared and y squared terms, an x and y term, an integer term, and even sometimes an xy term. Now for our purposes, this bxy term will never be present. That causes the rotation of a conic section, dramatically complicating things, so we'll keep things a little bit simpler. But we still need to be able to look at an equation and identify which conic section it is, so then we can go about rearranging the equation into a format that's more workable for us. And so we have kind of the following guidelines as to how we can determine which conic section type it is based on some of these coefficients. And the reality is it really depends on the x squared and y squared coefficients, a and c. The rest of these don't matter. They may or may not be there, and it does not affect which shape it is. What matters is the coefficients in front of the x squared and the y squared. Now, if one of those terms is missing, if either x squared is missing from the equation or y squared is missing from the equation, that implies that that coefficient is 0, either a or c is 0, which means it's a parabola. And if we think about the equation of a parabola, only one of the two variables is squared. Either the x is squared or the y is squared, not both. So if one of those two terms is missing, then we know it's a parabola. If a and c are equal to each other, meaning the coefficient in front of both the x squared and y squared is the same number, both the same number and the same positive negative sign, then it's a circle. So if it's negative 2x squared minus 2y squared, or if it's 6x squared plus 6y squared, then we know that it's going to be a circle. If the two coefficients are different numbers, but they are the same positive negative sign, 6x squared plus 3y squared, negative 2x squared minus 3y squared. As long as a and c are the same positive negative sign, even if they're not the same number, then it's an ellipse. If they're the same number and the same positive negative sign, then it's a circle. And then finally, if a and c are opposite signs, then it's going to be a hyperbola. When we think about the equation of a hyperbola, of course, it's based off the subtraction of the x squared and y squared pieces of the equation. And so once we've identified which equation, which conic section it is, then we can set about trying to rearrange the equation into a format where we can interpret its features. So in the example that we see in front of us, we're going to focus our attention on the x squared and the y squared terms. And so when we see that we have the same positive negative sign on both the x squared and the y squared, but different numbers, one is the coefficient in front of x squared, 5 in front of the y squared, that means that we are looking at the equation of an ellipse. And so once we've got that identified, now we need to rearrange the equation into the format where we would be able to find its features and graph. Now in the case of an ellipse, it may be handy for us to go ahead and write that down here. It's x minus h squared over, and then it's either a squared or b squared, depending on which denominator turns out to be larger, but we'll just write it as a squared for now, minus plus y minus k squared over b squared, and then equals 1. So this is where we need to go. So how do we do that? Well, it's really going to be a couple stages of completing the square. I'm going to need to complete the square on the x's, because we can see here it's x minus h squared, and the same thing for the y's. So right now what I'm going to do to get started is I'm going to rearrange my equation. So I'm going to have the x pieces come first, x squared minus 8x, then I'm going to leave a little bit of space, and then I'll have the two y pieces, 5y squared, and then minus 30y. And then I'm going to move the 39 to the other side, so I have equals positive 39. Add 39 to both sides. So now I need to work on completing the square for the x's and completing the square for the y's. In case of the x's, I can go ahead and complete the square as it is right now. I take half of the negative 8, that gives me negative 4, I square it, so that means I'm going to add 16 to complete the square there. And so I have to add 16 to the other side of the problem. Now in the case of the y's, I'm not ready to start completing the square there yet because I have this coefficient in front of the y's. So while I'm already set to go ahead and rewrite this x squared minus 8x plus 16 into x minus 4 squared, for this for the y's, I'm going to have to undistribute the 5 first. So if I undistribute that 5, I now have y squared minus 6y, and then on the other side I now have 55 if I add those two things together. And now I can go ahead and complete the square for the y's. So here I take half of negative 6, I get negative 3, square it, and so I'm going to add 9, but of course I haven't really added 9 to that side of the equation. I've added 5 times 9. So I've added 45 to both sides. So now I'm ready to factor the y's as well. So I've got x minus 4 squared plus 5 times y minus 3 squared equals 100 if I add those together. And so I'm getting close to having my equation in the format of an ellipse. My last thing is I've got my x's squared, I've got my y squared. I now need it to equal 1. So how can we do that? Well, I can just divide everything in the problem by 100. And so that leaves me with x minus 4 squared over 100 plus, and then in the fraction involving the y's, the 5 and the 100 reduce down to 20 on the bottom. So I'm going to have y minus 3 squared over 20, and then equals 1. So here I have successfully rearranged my equation into a format where now I can find the center of the ellipse, I can find the values of a, b, and c, and therefore the vertices and the foci, and be able to sketch the graph.